Hello everybody and welcome back. Today we're going to be talking about separation of variables. So in order to do this, let's look at an example problem. In this case, we have that the acceleration equals 1 over the velocity. So this could be just an object moving in a straight line. And so essentially what both of these are, we can say a of t equals 1 over v of t. And so as you can see, both of these are in terms of time. But there's also something interesting that we can note, which is that the acceleration equals the derivative of the velocity with respect to time. So what we can do is we can rewrite this, and we can say that dv dt equals 1 over v. And so what we have here, believe it or not, is a differential equation. So you have a differential here, and it's in an equation, so therefore it's a differential equation. It's a very simple one because the process that we're going to be using to solve it is relatively simple in this case. And so what we can do is we can say, okay, so we notice here, this is in terms of v, and this is in terms of v, but this is in terms of t, and this is just a constant. So if we could somehow get all of the v's together and then integrate it, and get all of the t's together and integrate it, then we would be able to solve this differential equation. And so in order to do that, what we're going to do is multiply by v on both sides. So we get that v dv dt equals 1. And then notice that, so this here technically, even though it's a derivative with respect to time, it's a fraction. I mean, it looks like a fraction. We can treat it as a fraction in this case. And so what we can say is we can multiply both sides by dt. And what we have over here is v dv equals 1 dt. And so we can just integrate this on both sides. So we can say that the integral of v dv and integral of 1 dt, and it's an indefinite integral because we don't need to put bounds on this. It's just, so we will get constants on the other side. And so what we have on this side is using the power rule, v to the 1 plus 1, so that's 2, divided by that new exponent. So v squared over 2 equals, and on this side, it's just a constant, but it's with respect to dt. So what we can say is that it's just t, and then on both sides, technically, we have a plus c and a plus c. But what we can do is subtract this c from this c, and we can just combine them into one term. So we can say v squared over 2 equals t plus c, because c is just a constant. It could be anything. And then rearranging this even further, what we can do is multiply by 2 on both sides. And what we have, well, and take the square root on both sides, but we'll do that in a second. So v squared equals 2t, and 2 times a constant is just going to be another constant, so we will, again, just call that a constant. And then taking the square root of both sides, we see that v equals, let's make that clearer, v equals the square root of 2t plus c. And technically this is plus or minus, but we're just going to treat this in the positive case, because we're assuming that the velocity starts at 0 and then it's accelerating. Let's just assume that it's going to be positive. And so what we can do is we can look at this graphically. So what we have here is this blue line right here represents the equation acceleration equals 1 over v. But then this curve that we have right here is an example of of the curve of the velocity equals the square root of 2t plus c. But what we can notice here is that this c, in this case, is when it's 0. So c equals 0. So this actually is just one of the possible solutions to this family of curves. So the question is, what is the correct solution for this general problem? Well, considering that there's a plus c, there's not going to be a specific solution unless we have initial conditions. And so really, what it looks like is there are a whole bunch of curves that could possibly represent this. And of course, these are like filled in like this, so there are plenty of curves in between all of these. It extends much further beyond this, it extends below this, and all of these are possible solutions to the original equation a equals 1 over v. And that is a quick introduction to separation of variables.